At 700 miles per hour, the sky stops being a horizon and becomes a boundary to be broken. In an age defined by speed, nations race, not just to strike first, but to outpace the future itself. And at the heart of this new contest stands a machine with an unlikely name, Elon Musk. S700 MPH Hyperloop concept could become the fastest way to travel a fighter jet born from a radical idea and sharpened into a weapon of air dominance. It began, strangely, with a transportation dream. When engineers studied the early Hyperloop vacuum tube transport system pushing human travel towards 700 miles per hour, military planners took notice, not of the passenger pods or infrastructure, but of the physics. Reduced drag. Aerodynamic purity. The idea that speed, achieved efficiently, could reshape warfare. By the late 2030s, rising global tensions and the emergence of near-peer air adversaries forced several allied nations to look for a new solution. Hyperloop Hyper-efficient Interceptor that could reach its target faster than an opponent could rethink the battle. The result was a program codenamed Project Apex. It would create a next-generation fighter using lessons from low aerodynamic studies and high-speed tube transport airflow modeling. Engineers joked that the aircraft was the Hyperloop with wings. The nickname stuck. Eventually, so did the formal designation. HX-7 Hyperloop Interceptor, shortened by pilots to simply the Hyperloop. From a distance, the HX-7 looks like it was carved by wind itself. A narrow, blended fuselage tapers into forward-swept wings designed to stabilize air pressure at transonic speeds. Its surface is seamless, no protrusions, no vents visible to the eye. The airframe is built from a hybrid titanium lattice and carbon ceramic composite capable of withstanding enormous thermal stress while keeping structural weight astonishingly low. Under its skin lies the heart of its stealth. Radar-absorbent internal weapons, bays, and distributed sensor apertures that eliminate traditional hotspots for radar reflection. Its designers favored a philosophy of active stealth, where the aircraft continuously shapes and manipulates its radar signature in real time through onboard computing. Inside the cockpit, though, cockpit hardly applies anymore. Pilots sit within a deep, armored immersion dome. A full surround augmented reality display replaces traditional gauges. Instead of looking out of a canopy, pilots view a stitched, ultra-high-resolution, 360-degree rendering of the world outside, fed by dozens of cameras and sensors. It is a fighter without windows, yet one with unmatched awareness. The HX-7's engine is the true breakthrough. Developed by Aerodyne Systems, the A79 variable cycle turboaerojet can switch airflow modes mid-flight. At lower altitudes, it behaves like a high-pass turbofan for efficiency. Climbing through the thin air, it transitions into a ram compression modo, allowing sustained speeds above Mach 1.1 without afterburner. When the engine's plasmast stabilized, afterburner drives the aircraft to Mach 1.9 in level flight, with short bursts capable of surpassing the symbolic 700 mile per hour Hyperloop threshold even during aggressive climbs. Its climb right over 65,000 feet per minute grants it the ability to leap into the stratosphere in under a minute, reaching a service ceiling near 68,000 feet. Range was a priority. Internal fuel and adaptive cycle efficiency give the jet a combat radius of approximately 850 nautical miles, extendable with 2 stealth tank bays that retract into the fuselage after transfer. Despite its sleek design, the HX-7 carries formidable weaponry. Its internal base house AIM-260 long-range air-to-air missiles, next-generation Astra 3 hypersonic interceptors, and a compact twin pack of GBU-59 precision glide bombs for limited strike mission. A nose-mounted directed energy turret provides short-range missile defense and can disable incoming threats in fractions of a second. Its radar suite, the NAPR-92 quantum array, uses multi-band and multi-static signals to track stealth aircraft at long distances, paired with electronic warfare systems capable of jamming, deceiving, and even injecting false data into enemy radar networks. The Hyperloop becomes not just a fighter, but an information weapon. The aircraft's operational history is young, yet impressive. First deployed with select Allied Rapid Response Squadrons, the HX-7 made its mark during high-intensity multinational exercises. In simulated intercepts, it routinely reached its target area 40% faster than conventional fighters. During one well-known drill, an HX-7 squadron managed to destroy an entire formation of 4th and 5th generation fighters before any opposing radar detected them. In limited real-world missions, most of which remain classified, the Hyperloop has reportedly escorted high-value assets, executed high-altitude reconnaissance, and intercepted foreign aircraft attempting to test Allied air defenses. Pilots describe it as effortless at speed and eerily quiet, like flying inside a thought. The HX-7's doctrine revolves around speed superiority. Rather than lingering in contested airspace, it darts in, strikes, and vanishes before enemies can organize a response. Tactically, it behaves like an aerial scalpel used to disrupt enemy plans, decapitate forward sensors, and strike vulnerable points before a wider engagement unfolds. For pilots trained on legacy fighters, adapting to the jet is like learning to think half a battle ahead. Comparisons are inevitable. Against a Chinese J-2OB, the HX-7 holds the advantage in climb rate and sensor integration, though the J-2OB may outrange it on internal fuel alone. Against the Russian Su-57M, the Hyperloop is stealthier and more agile in high-altitude intercepts. But the Su-57M retains superior maneuverability in slow-speed dogfield. Such engagements are increasingly rare in modern air warfare. In the end, analysts agree, the HX-7 isn't meant to fight like its rivals, it's meant to outrun and outthink them. Today, the jet serves with select NATO air forces, with additional units planned for export to close allies. Upgrades in development include a hybrid energy-assisted engine, enhanced laser weaponry, and autonomous teaming modes allowing the HX-7 to command swarms of unmanned escorts. And yet, beyond the technology, beyond the speed, there is something almost poetic about the Hyperloop. A fighter born from a dream about peaceful transportation became a symbol of deterrence in a dangerous world. It embodies a paradox of the modern age, that the faster humanity strives to connect, the more vital it becomes to defend the skies that separate us. In the silence of the upper atmosphere, where the HX-7 roars toward the edge of the blue, one truth becomes clear. Speed is more than power. It is intention. It is warning. It is the future, arriving before anyone else can see it.